Hey everybody, today I want to introduce you to what I call the W.I.S.H table. And first, I'm going to show you an object, okay? Simple Lego Duplos. If you've got little brothers or sisters running around at home, you've probably stepped on one of these and it hurt. No discernible pattern. We've got some blocks, but what if I called this step 1? And I called this step 2. Do you think you could figure out what step 3 would look like? And how many blocks you'd need to make it? I'll give you a second, don't worry. Yeah, you're right, it's not that hard. It'd probably look like this. Now, color aside, the number of blocks and how they're built, I bet you could probably figure out what step 4 looks like too. So we're going to use a W.I.S.H table to see if we can figure out a lot of other really cool things. So W.I.S.H stands for what I see happening. And first, I'm going to build a table. Second of all, I got to talk about what's actually happening. Now, in my class, we start counting at 0, and then 1, step 2, and we only got to step 3. So what did step 1 look like? Let's bring it back in. Put it at the top of the screen. Well, I see a bottom row of 3. Call it the foundation here. And it looks like there's 2 on top of that. And 1 on top of that. And 1 on top of that. Now over here we're going to put our total. How many blocks we're talking about. So if I have 3 plus 2 plus 1 plus 1, 3 plus 2 is 5, 6, 7. Now, what about 2? Now, there's no real specific way you have to do this. This is what I see. It's not called what you have to see. It's called what I see. So I see still 3 at the bottom, plus now there's another 3 at the bottom, plus 2, plus the 1, plus the 1. And now I can start to see a pattern. Like this 2 plus 1 is happening every time. So instead of putting 2 plus 1, could I just put plus 4? And then over here, 3 plus 3, well, that's repeated addition. And we know repeated addition is nothing more than multiplication, so it's actually 3 times 2. Now, I know that was a few extra steps, but what I like to do is I like to simplify my math, so I don't have to write as much next time. So this time, when I bring in step 3, and I look at that, well, I have how many of those 3's? 1, 2, 3. So instead of putting 3 plus 3 plus 3, I can just say 3 times 3. And then, instead of putting plus 2 plus 1, I can just say plus 4. Now I have to figure out the total in both of those. Well, 3 times 2 plus 4 is 10. 3 times 3 is 9. 9 plus 4 is 13. How am I doing so far? So now, if I look at this, will this pattern continue up here with 1? Well, I can take the 2 plus 1, erase that, and make a plus 4. But what about this? I'm just left with 1, 3. Can I put times 1? Sure. Now here's a question. If this is step 3, and this is step 1, what does step 0 look like? Well, since we seem to be taking away 3, 2, 1, 0. So 3 times 0. We're multiplying by the number in this box. 0 and 0, 1 and 1, 2 and 2, 3 and 3 are being multiplied by this coefficient. There's a fun math term for you. Plus what number is always staying consistent? That's our 4. It's always there. So now I know that if I had a step 0, it would be a 3 times 0 is 0 plus 4. So how many blocks does this take? 4. So let's see if we can take it to a step where we can't have any blocks because I'm out of Legos. So what if I asked you for step 8? If you know this pattern and you can see this table, what number do you know is going to be consistent over here? The 4, right? This is actually called the constant because it just keeps showing up, never goes away. And then if you go over here, this number in front never changes. It's called the coefficient. It's always there. And the number in here that's always changing is called a variable. Ready to see my hand signal for variable? Take your hands, put a 2 on one hand. When you hit the other hand, pop them up. It's a 2 or a V for variable. Because variables can represent lots of different numbers. So I can choose what my variable is. 0, 1, 2, 3, or 8. And if I put it in as 8, then it goes in here. And I can find out how many blocks I would need to make the 8th step. 3 times 8 is 24. 24 plus 4 is 28. Pretty cool. But now here's where math gets really cool. What if I said I wanted to know the expression for any number? Now, there's a really cool math term for this, and it's not too complicated. Any number. Well, what does number start with? It starts with an N. So we call this the nth term. Looks kind of like an R. Let me see if I can fix that. There you go. So if I look at this pattern now, I know that's not a number, and that may be scary, but it represents all the numbers. So the 4 doesn't change because it's consistent. It's the constant. Consistent constant. The 3 doesn't change because the coefficient is still there, and the coefficient is the same. And then our variable is just n, representing any number. Now, this is the part where people get confused. I've just created my wish table. I can tell you that you can pick any number here, and as long as you put it in here, multiply it by 3 and add 4, you're going to know how many blocks. But what do you put in here as your total? Well, don't overthink it. The answers are literally right in front of you. 3 times n plus 4. That's an expression. It represents a single number. You just don't have the n yet, which is okay. You'll get it on a different problem. So this kind of task is here so that you can take concrete things, literally something that you can see, hold, whether it's the number of tables in a room or bricks in a Lego stack, and take what you see and begin to see patterns. And when you can develop that pattern, you can start assuming the coefficient, the constant, and then determine the nth variable.